Okay, we are back. Now let's take a look at cosecant. And we know that cosecant x is 1 over sine x. And we can similarly figure out what this picture is going to look like. Actually, I think I'm going to make this one blue, which I probably should have wrote this in blue. But so if sine x is cosine x shifted over by 90 degrees or pi over 2 radians, these graphs should look similar, cosecant and secant. Well, let's see. When is sine x 1? Well, it's going to be 1 at 90 degrees. So we'll put this here. Now, what's going to happen as we know that sine x is 0 at 0 and 0 at pi. What's going to happen is you're going to be taking 1 and dividing it by a small positive number. And when that happens, this is going to shoot up. By symmetry, the same thing's going to happen. This is going to do this, and this is going to do this. What else? So this is looking a little crowded. However, actually, I'm not going to spend a lot of time on this because these basic graphs do look a lot like each other. You just have to figure out where what is what. Well, when is sine x negative 1? Well, sine x is negative 1 at negative pi over 2. So I'll put this here. As sine x goes to 0, from this side, from the negative side, sine will go to 0 negative numbers. It'll be small negative numbers, same as to negative pi. So when you take 1 and you divide it by a very small negative number, it goes to negative infinity. So this is going to look something like this. And I see that if you wanted to complain about my artistic abilities, and notice this is too low right here, all mathematicians who teach should have to go to art school because the ability to draw a good graph is pretty important. This is my humble attempt. What about when, let's do maybe one more of these. How about when sine is 3 pi over 2? We know, so when sine is 3 pi over 2, it's 0. We know that when sine of 3 pi over 2 is negative 1, so I'm going to do this. And like I said before, it's going to be sine is negative here, and it's going to be approaching 0 from both sides, so once again, this is going to negative infinity. And I guess what I just wanted to try and get across was that this is just shifted over. These graphs are essentially the same. They have many similar properties. It's just a matter of where they are. Like I said, needing the graph of these functions specifically, it doesn't really show up that much, or it hasn't for me. These are the important ones. Let's look at tangent and cotangent. Okay, now let's take a look at the graph of tangent x. We know that tangent x is sine x divided by cosine x. Put a picture of this up on the board. So have you noticed I always do this? I don't make these long enough. Okay, so we know that we have to be worried about where cosine x is 0, and these will be asymptotes of the function, and I'll put them in red. We know cosine x is 0 at pi over 2, negative pi over 2, negative 3 pi over 2, positive 3 pi over 2. I'm just going to draw them in. So the function cannot touch these lines. Now we need a couple points of interest to think about what's happening here. We know that sine of x is 0 at 0, cosine x is 1, so tangent x is 0 at 0. What else can we use here? Here's where it really helps to have a knowledge of these functions. Although, so the truth is, if you have a good graphing calculator or a computer program, this is a piece of cake. You can just make them do it. What is the tangent of pi over 4? Well, this is 1, and this is the tangent of 45 degrees. Why is that? Well, so this is the line y equals x, and I'm not doing a great graph up here. This is cutting, remember tangent is the slope right here. This cuts this 90 degrees into 2 equal sections, so the tangent of 45 degrees, which is pi over 4, is 1. So this is positive. This is all I'm looking for to figure out what's positive. What's going to happen as this goes to pi over 2 from here? Well, at pi over 2, this is going to be 1, but this goes to 0. When you take and have a number go to 1 and divide it by a positive number that's going to 0, this thing is going to blow up. So this is going to mess. A similar argument can be made. We know that sine of x is an odd function. So we have this. The tangent of minus 45 degrees, minus pi over 4, is equal to the sine of minus pi over 4 divided by the cosine of minus pi over 4. Cosine is an even function. That minus sign gets killed. So this is going to be 1 over the square root of 2, which is what it is, incidentally. Cosine pi over 4 equals sine pi over 4, which is 1 over the square root of 2. So this negative sign is going to come out of the sign, and this is going to be the negative of sine pi over 4 divided by cosine of pi over 4. So this is just going to be negative 1. And I went through that just to point out that this is going to now look like this. Ooh, ouch. That's really ugly. So here's what this graph looks like on the interval from negative pi over 2 to pi over 2. It just is periodic and looks like that everywhere along the graph. Okay, and this is a particularly ugly graph. Sorry about that. It's probably good to know what this one looks like. This shows up a lot. Notice if this was drawn correctly, there would be, this would have period pi. It does have period pi, but these are all supposed to be identical. So what does cotangent look like? Well, let's see if we can figure it out just from what we know about even and odd functions and what's going on with this. We know that cotangent of x is equal to cosine x over sine x. So right away the asymptotes are going to change to where sine x is 0. And the asymptotes where sine x is 0 is going to be anything at pi, 0, 2 pi. So let's put these in. So these are the asymptotes for cotangent. Okay, and now we're going to take a quick break to reload some film, and I'll come back and we'll draw this up.